Another equation practice video, and this one's specific heat capacity. So it's E equals mc theta. That's the funny letter there, theta. You may have seen it as delta T. Delta T just means change in temperature. Delta is another Greek letter that just means change. So you can use whichever you want. Delta T is change in temperature. Theta also means change in temperature measured in degrees. C is the specific heat capacity. Specific heat capacity, is measured in joules per kilogram per degree. Mass is in kilograms and energy is in joules. If you've not seen this before, I've got a video that explains it in the energy playlist. So if you want to check that out, please do. And I'm going to get rid of this and then just attempt question 1 and 2. And I'll take you through the answers. Alright, so remember to pause whenever you need to. So let's have a look at the first one. So it's got a block of metal, has a mass of 1.04 kilograms and a specific heat capacity of 5,530 joules per kilogram per degree. The block is heated up and increases in temperature by 39.9 degrees Celsius. And we're going to calculate the increase in thermal energy. So that's just E. So this is straightforward. Energy is mc theta or mc delta T, and then just pop the numbers in. So mass 1.04, specific heat capacity is, I can't speak today, I don't know what's wrong with me, 5,530 multiplied by change in temperature 39.9, and if you calculate that you should get 229,473 joules. Alright, let's look at number 2. You can obviously pause and do number 3 if you want at any point in time. Number 2, a block of metal has a mass 3.68 kilograms and a specific heat capacity of 2,650 joules per kilogram per degree. The block is heated and the thermal energy of the block increases by 954 kilojoules. So that just means you have to times by 1,000. At this time we're going to calculate the temperature change. So E equals mc theta. And then what I'm going to do first of all is rearrange it and make theta, the temperature change, the subject. So I've got a times m and a times c attached to theta. So I need to move them to the other side. So the opposite of timesing by mc is simply move it to the other side and divide by mc. Then we just need to put our numbers in. So the energy is 954 kilojoules. So that's 954,000. Divided by the mass, 3.68. Multiplied by the specific heat capacity of 2,650. Put that in your calculator. And that gives a temperature change of 98 degrees Celsius. Right, let's look at the third one. If you want to pause and have a go at that. Number 3, a block of metal has a mass 1,400 grams. The block is heated and the temperature increases by 62.1 degrees Celsius. The thermal energy of the block increases by 0.479 megajoules. And this time we're going to calculate the specific heat capacity. Alright, so E equals mc theta. We're going to rearrange to find the specific heat capacity first. So we need to make C the subject. So we need to get rid of a times m and a times theta. The opposite of times m by m theta is to divide on the other side. So that'll give us the specific heat capacity. Now the energy is 0.479 megajoules. So what you need to do with that is times that by 1 million and put that into your calculation. Or mega means times a million. You could do it in standard form and it's 0.479 times 10 to the power 6. It's completely up to you which one you do. If you just times it by a million, it's the exact same thing. Divided by the mass. So we've got 1,400 grams. Mass has to be in kilograms. So that's 1.4 kilos. Multiplied by change in temperature, 62.1. So if you calculate that, the specific heat capacity will be 5,510 joules per kilogram per degree. Right, let's do 2 more. So number 4 is straightforward. Number 5 is an extension question, and it does have synoptic elements, which means you'll have to use physics knowledge from other areas of the GCSE. So let's do number 4 first. So a block of metal has a specific heat capacity of 4.58 kilojoules per kilogram per degree. The block is heated and the temperature increases by 142 degrees Celsius. And the thermal energy of the block increases by 2,760 kilojoules. And we're going to calculate the mass. So E equals mc theta. What we need to do is make m the subject, so we need to get rid of a times c and a times theta. So to do that, we need to divide on the other side. So energy divided by c theta will give us the mass. Then we just need to sort the units out. So the energy, 2,760 kilojoules, so you could just times that by 1,000. So I'll do that in standard form, times 10 to the 3. Times it by 1,000 and using the full numbers perfectly fine if that's what you wish to do. Divided by C, so that's 4.58 kilojoules per kilogram per degree. So you have to convert that. We need to times that by 1,000 as well. So that's 4,580. Multiplied by changing temperature of 142. So if you pop that in your calculator, that gives us the mass, 4.2 kilograms. Hopefully that went okay. Let's have a look at number 5 then. So this is extension work. So if you've not done it already, if you want to pause and have a go, and then I'll take you through the answer. So water has a specific heat capacity of 4.2 kilojoules per kilogram per degree. 1.2 kilograms of water are heated, should be is heated. It's terrible English. Let's highlight that for terrible English. It's heated from 20 degrees to 100 degrees in 3 minutes using a kettle. Calculate the current. So that might seem a little bit tricky. Let's have a look. So first of all, let's calculate the energy transferred. So energy is mc theta. So the mass is 1.2 kilograms. Multiplied by the specific heat capacity of 4,200. We need to times by 1,000 because it's kilojoules. Change in temperature, 20 to 100 is 80 degrees. So that gives us an energy transfer of 403,200 joules. This is obviously assuming that the kettle is 100% efficient, which it wouldn't be in real life. But GCSE physics is fine. So we've got the energy transferred. Now we need to get the current. So what I'm going to do is use this equation. Energy transferred is current times time times voltage, or energy is ITV. And what I'm going to do is rearrange to find the current. Now you might be thinking, well, we don't know the voltage either, but wait and see. So let's make I the subject. So we need to get rid of a times TV. So the opposite of timesing by TV is divided by TV. And that will give us the current. So the energy transferred is the 403,200 joules, which we just calculated, divided by the time. So we've got 3 minutes, which we need to turn into seconds. So that's 180 seconds, 3 times 60. Multiplied by the voltage. Now this is a kettle, so it's running on mains electricity. Mains voltage, which you need to know, is 230 volt average. Okay. Just as a bonus bit of information, you also need to remember the frequency of mains electricity is 50 hertz. We don't need that for this question, but why not? Right, if we put that into our calculator, that will give us the current, which is 9.7 amps. If you got that, really well done. If not, if you want to retry it, well, it's completely up to you. You just need to rewind. Anyway, thanks for watching. Hope you found that helpful, and I'll speak to you soon.